All right, numbers have stabilized, so let's go. So a very warm welcome to all you Druids out there. This is the fifth session of our third virtual Druid Summit. Over 450 people have registered from across the world to listen to all of our wonderful speakers, and brushing your teeth is optional. It's great. So my name is Rachel Podreski. I run the community program here at Imply. And we're joined this hour by Himanshu Gupta, who's a principal software engineer at Splunk. So before we get started, just a few little housekeeping rules. All you attendees will be on mute throughout the session, but that doesn't mean you can't get involved. On the contrary, we want you to get involved. So please ask any questions in that Q&A panel. It's down at the bottom. Does everybody see it? It says Q&A. That's a place to ask questions. And at the end of the presentation, I will hand out any of those questions to Himanshu. Anything that we don't get to, we will follow up with a blog post. And of course, links to the full presentation and the accompanying slides will be sent following the sessions. So this talk concerns running Druid on Kubernetes with the Druid-operator, and it's going to be super interesting for all of us looking at containerized deployments. So Himanshu, it's over to you.
Thanks, Rachel, for the nice introduction. Hello, welcome everyone to this introductory talk on Druid-operator for Kubernetes. So the agenda for this talk would be to just showcase a few use cases for Druid that we had at Splunk, and then talk a little bit about Druid. I know the audience here is probably very familiar with Druid already. Then talk a little bit about Kubernetes and the operators and the Druid Kubernetes operator. There's a lot to talk about when you're kind of trying to deploy things on Kubernetes, because there's a whole set of technologies that get into the picture. I try to introduce some of them, but it's like impossible to talk about all of them, but I'll go through probably quickly Kubernetes and operators, and then probably spend a lot more time on the Druid Kubernetes operator specifically. So let's get started with like how it all began for us. So at Splunk, one of the use cases we use Druid for is in a product called Splunk Business Flow. It's a process mining product, which basically means if you own a business and customers come to you, buy stuff from you, and it gets delivered to them, and you want to kind of track the whole flow of how a user went through, like coming to your website to getting stuff delivered and paying you money. And most of the time you kind of have an image of the process in your mind that customer comes to your website and buys stuff, but sometimes they are calling the call center, credit card payment are getting denied, etc. So this kind of shows you the flow of all the users, where you can pinpoint the bottleneck in terms of your business process and optimize your business processes. Another use case that we use Druid for at Splunk is in the trace analysis. So, you know, all the major companies are trying to go on the Kubernetes in the microservices world. And typically the bigger systems are deployed in terms of many, many different microservices. So one user request to your business might touch tens or 50s or hundreds of microservices. And you want to kind of trace down the path of request across all the services it is going through, to figure out the bottlenecks or to do the root cause analysis and things like that. So it's part of a Splunk observability suite. So yeah, one of the things that I wanted to highlight about Druid is, like, of course, everybody talks about Druid's, how cool is Druid and the performance, latency, and query throughput, etc. For me personally, I think one of the big advantages with Druid has been the customizability that Druid offers. You can pretty much bend it to do anything. So as you see, like, we have very flashy graphs in both the products, and they are possible because we are able to customize our own storage formats, our own aggregations, and build virtual columns and all those other nice sorts of things. So I know the slides were a little bit in reverse order. I talked about the Druid advantage before introducing Druid, but I know the audience here is well versed with Druid. So it's the customary slide about Druid. It's the high performance real-time analytics database, and that's my Druid talk. In terms of the architecture, I think when we are deploying Druid, we are concerned about like how many different node types Druid has. So as you know, Druid has a different set of nodes like coordinators, overlords, routers, brokers, middle managers, historicals, all of which function different roles inside of a Druid cluster. And then you have few external services that Druid cluster needs in order to work, which would be a metadata store, Zookeeper, and deep storage. All right, now let's switch gear to Kubernetes. So Kubernetes is a platform or system to let you deploy containerized applications on top of a set of machines. Those machines could be bare metal machines, they could be EC2 instances in AWS, or virtual machines inside the GCP. So Kubernetes has its own advantage. It's a fairly popular project. So let's move. So in terms of deployment, I wanted to touch upon in general what Kubernetes design principles are like. Of course, like when you're working with Kubernetes, to do things with Kubernetes, you submit it a request and it obliges and does the thing. And at the core of Kubernetes, it always follows this control system pattern where you'll send a request to Kubernetes to do something. It will have a set of controller processes running, which are kind of continuously watching what user has updated in terms of what they want to deploy or do. And then controller process is also continuously watching what the current state of the world looks like and kind of keeps on doing a reconciliation between what user wanted the world to look like and what the current state in the world is. And this theme comes up in pretty much everything that Kubernetes offers. Okay, so here we talk about the target state is what you give to Kubernetes, and then it tries to do certain actions to make that a reality. And the way you specify that state is in terms of the YAML resources to the Kubernetes, and Kubernetes comes with a whole lot of different built-in resources like stateful sets, deployment services. The stateful set deployment is basically where you say, hey, this is my Docker image, this is the number of replicas I want, go deploy it on the cluster. So that basically give me X number of processes running a particular web application and things like that. So for an example, if let's say you have a simple web service that you wanted to deploy on a Kubernetes cluster, you would typically create these kind of YAMLs where these will contain details of like where your Docker image is, how many replicas of the web service you want to have, what is the configuration you want to have for them, and a resource to talk about like how users are going to reach your service, whether you want to create a load balancer and things like that. So you technically could submit these three resources in a Kubernetes cluster, and then it would give you this kind of an infrastructure view where you have a load balancer or some virtual IP that your user can connect to. And then depending upon the policy of load balances, they will reach out to one of the replicas that your web service might have. So that's the essence of how people deploy things on Kubernetes. Now we come to the part where you want to deploy Druid on Kubernetes. And when we want to deploy Druid on Kubernetes, this is kind of the picture that comes to our mind. But the reality is this, like there's Kubernetes and we are not deploying one web application, we are deploying this whole big thing. So of course we want to be able to deploy all the Druid nodes that we see on top. And then typically, I mean, at least in my experience, we don't deploy metadata storage and deep storage on Kubernetes. We have been running on the cloud, and clouds have like pretty nice offerings that you can directly use. Like Amazon has RDS and Aurora database as a service and S3 buckets to be used at deep storage. And Zookeeper, we do deploy it on Kubernetes, and this talk is not about that, but basically like I described for the web application, Zookeeper can pretty much be deployed the same way. So let's see. So if we manually wanted to deploy Druid on Kubernetes, we'll at least have to, like just drawing the parallel with that web service example, Druid has these 6 different type of nodes or web services. So you'll have to at least have these 6 stateful set resources or another type of resources, 6 services so that you can talk to the processes when they come up, 6 configurations, then one common configuration that kind of gets applied to all the web services. And this is actually a smaller set. You will have many, many more YAMLs if you were to manually deploy Druid on Kubernetes. But anyways, if you were to build all of this by hand, submit those to Kubernetes, you will have a running Druid cluster eventually. Now, the problem is you're not just deploying one Druid cluster, right? You're deploying a dev cluster, a staging cluster, and production cluster. In fact, multiple production clusters if you care about the cross-region availability and things like that. So it manually maintaining or trying to maintain scripts that do all of this becomes very difficult to manage pretty quickly. So we wanted to come up with a generic solution that could let us manage all of this mess without dealing with it every day. So I know this slide has a lot of text, which is probably an anti-pattern, but basically what this is saying is like, can we write yet another simpler application that takes, to which we can give a simple Druid spec where we are talking in terms of, okay, we want to deploy a Druid cluster. These are the number of brokers, these are the number of historicals, and this is the configuration, and these are the JVM parameter. And then that application actually deals with Kubernetes and creates all the resources that Kubernetes needs. And that's pretty much the essence of Druid-operator. So instead of like submitting directly the Druid Kubernetes specific resources, you would just talk to the Druid-operator application, give it a simpler Druid resource, and that Druid-operator application in turn will talk to Kubernetes and create everything necessary to manifest a Druid cluster in the Kubernetes setting. Now, it becomes more interesting when we start to say, oh, where do we deploy this application? Like, we want to deploy this application somewhere before it can do things. In terms of the operator, when we talk about Kubernetes operators, those smaller applications can actually be deployed on Kubernetes itself. So your operator is itself an application that you deploy manually on the Kubernetes itself, and then that comes into existence and deploys the Druid cluster for you. So now in terms of why operator and not something else, and there are like, I didn't talk about those, but there are many different ways you could have managed your Kubernetes deployment. But we went with the operator route because it's easy to create like generic applications, which is very easy to reuse across different teams and share an open source and have it shared in community also. So Druid-operator at this point is open source. Anybody can use it. And I'm sure a lot of you people in this talk already have seen it. It is getting some adoption. So that means like there are multiple people using it across the industry, which kind of gives it more stability, because there are corner cases, there are different people will hit. So it kind of gets a lot of testing done and has better quality than anything else. Another thing is like being an application itself, it's just written like any regular application in a generic programming language. So you can do unit testing, or all the nice development workflows can be done to improve its quality. On top of that, like one major difference the operator pattern have compared to the scripts for managing things is like an operator not only can deploy a Druid cluster, it can also manage the Druid cluster, because it is a thing which is continuously running and watching how the world looks like and can act to correct the state all the time instead of just like fire and forget kind of a scenario. So that's the reason we decided to write an operator. And also it's like a pretty general problem in Kubernetes community. If you read about it, recommends this approach of like for bigger distributed systems, it's a good idea to have dedicated operator for those. So you will see operator for etcd, Kafka, and all the other major distributed systems. Now, before I kind of touched upon what Kubernetes operator is. So basically, different people talk about Kubernetes operator in different ways. I kind of look at it as yet another application that gets deployed on K8s, and instead of doing some specific things, its main job is to deploy another bigger, more complex application on the Kubernetes. But at the end of the day, operator itself is just yet another application running in the Kubernetes. What makes operator special is that somehow you have to tell operator like, this is my Druid spec and go deploy a Druid cluster. And Kubernetes provides some extensibility features in terms of the custom resources. So like we talked about Kubernetes having built-in resources like stateful sets and deployment and a whole lot of things. And Kubernetes has built-in controllers, like when you submit a stateful set, a stateful set controller comes in and does the job that spec says. Similarly, you can define your own custom typed resources on Kubernetes. So for example, the Druid operator creates a Druid type Kubernetes resource. So the way you tell the spec to the operator is like you would give any other spec to the Kubernetes. So you will still be using Kubernetes command line tools to submit the spec, where you'll say, okay, this is the Druid spec, type is Druid, and do the thing. And then the operator process can use a watch API provided by Kubernetes to continuously watch for all the resources of type Druid that get submitted to the Druid cluster. So that the operator knows what are all the Druid clusters I'm supposed to manage and create and do things with. So like operator is just an application, but it always uses these two features of Kubernetes to kind of look and behave as if it was part of the Kubernetes itself. Then even with the operator, it's the same design approach as I talked for Kubernetes. The operator is also running somewhere inside the Kubernetes cluster as a pod. As a user submit your custom resource, which in our case would be a Druid spec, to Kubernetes API server component, which hosts all the resources submitted to Kubernetes. And then operator is just watching the specs for all the Druid clusters and then doing actions to create the Druid cluster. So now that we know Kubernetes operators, we can talk about the Druid Kubernetes operator. So as I said, it's an operator for managing lifecycle of Druid clusters. So that's like the distinction. It doesn't just like deploy and forget about the Druid cluster. Like its aim is to manage the whole lifecycle of the Druid cluster, always watching and doing things necessary rather than just like deploying everything and forgetting about it. So what does it currently do? Like if you were to take the Druid operator from the community today, these are kind of the features it has right now. So it can deploy Druid clusters. It can do constant reconciliation. That is, for example, if you changed your Druid cluster in some way, manually deleted something accidentally, then the operator will go and reset the state and bring it back to what it is supposed to be. It can also manage the rolling updates. So for example, you want to change the Druid version or make any config changes, or you want to make any cluster topology changes. That is, you wanted to increase the number of historicals, or you wanted to add a cold tier of historical and hot tier of historical and things like that. You can just change the spec and the operator can automatically do a rolling update of the whole cluster to manage and change the Druid cluster. And for any reason, or whenever you're done with a Druid cluster, maybe it was a test cluster, you can submit a delete for the Druid spec, and the Druid operator will manage the destroying of whole of the Druid cluster from the Kubernetes. So it will do everything necessary to clean the, wipe out the slate there. Of course, like everything, there are some gotchas and we'll talk about those, but that's what it currently does. In terms of the future, I would like to see it replacing everything that a Druid user needs to do in terms of like managing a Druid cluster. So Druid itself as a software does a lot of things, and then people using Druid have to do a lot in terms of just managing the Druid clusters. And these are some of the things that I typically see happening that Druid users do. And I would like to see Druid operator evolving in this direction so that for a Druid user, it becomes less and less of a work to have and manage a Druid cluster and letting operator manage most of the things, which are kind of more mechanical than anything else. So some of the immediate future things is, of course, like we have a Druid repository, Druid operator repository. There's a bid somehow doing some integration testing in there so that it actually deployed a Kubernetes cluster and deploys Druid and manages that so that when people submit PRs, they kind of get a better testing done. But that's like different. But in terms of the capability itself, I think some things we could do better is like managing MiddleManager upgrades, especially when you have real-time ingestion. So MiddleManagers have enable disable API where you can kind of disable a MiddleManagers and you let it drain all the tasks and then kill it rather than just saying all MiddleManagers upgrade one by one. It could also improve things in terms of auto-scaling MiddleManagers. Like Druid itself has a lot of different ways of auto-scaling MiddleManagers, but I think operator can do a lot to help in that area. Another thing it could do is like, of course, it is managing the Druid cluster, deploying it and keeping it up all the time. One thing it could do, it could provide better visibility inside the Druid clusters, like how the health of the cluster looks like and sending alerts just in case something is wrong with the Druid cluster. And I see all the Druid users having their own things to this part, and it could be generically done inside the operator. Another thing it could do is like people manage the Druid coordinator overload dynamic configurations and load rules, etc. outside in terms of managing Druid deployment, and they could potentially also be managed by the Druid operator in a very reusable generic way. Maybe it could manage the tasks also. And there are a lot of features in Kubernetes itself for auto scaling. There's some support in operator already, but that area of the Druid operator can be significantly improved. So I think like in the long run, operators should basically take as much boilerplate and mechanical work away from the Druid users as much possible. So that's the plan. So, okay, I think we all understand in theory what operator is, how it works, and what it does or what it could do in future. And the question is like, great, I'm sold. I want to use this. How do I get started? So these slides will be shared. You can, of course, click the links here. But basically, if you go to the Druid operator documentation on this getting started file, you'll see how to kind of install the operator on your Kubernetes cluster. There is an example Druid cluster spec that you can use right away to deploy like a tiny Druid cluster and see it in action. If you open that spec, this is what kind of looks like. The interesting thing is the kind Druid thing there, that is an instruction to Kubernetes, like this resource type is Druid. So this is the custom resource we were talking about. So Kubernetes has its own built-in resources like stateful sets, etc. And we are able to create our own type of resources using the Kubernetes custom resources extensibility features. But anyways, so yeah, once you do this, you will have a Druid cluster running. So you can do the regular Kubernetes things to see like what are the pods running. So you can run these commands to see like what the Druid cluster looks like. You can see the logs of different pods, especially when things go wrong. You should be, so operator is publishing a lot of logs and events for the spec you submitted. So you can kind of run these commands to see those logs and events just in case things didn't turn out to as you expected and something is wrong. So it helps with debugging a lot. So for example, you can look at the operator log as it is doing stuff. It is publishing a lot of logs like, hey, I'm deploying a Druid cluster, this is what I did, and these are the errors I faced and things like that. You could look at your specs events. So you would see things like it kind of operator publishes the events like what it has done on that specs behalf. Like I have created these config maps and stateful sets and whatnot, and it kind of tries to log everything here in terms of the event. So this is also a helpful place to debug with respect to what the operator is doing. Then when you describe your spec, it also kind of publishes the current status. So operator is keeping track of all the other resources that operator has created on your behalf. So you can kind of get a snapshot of your Druid cluster from this single command. Okay, so that hopefully gets you set up and get a Druid cluster running. As you get to use the operator or just deploy Druid in general on the Kubernetes, there are some of the common problems that people have faced, and I think everybody at some point faces. So I wanted to kind of show them upfront so that you wouldn't spend a lot of time figuring those out. One of the things that happens is it's actually a issue on the Kubernetes itself. Like technically, when you submit stateful set resources and you have persistent volumes in them, and I know I haven't talked about persistent volume and all that stuff in this talk. If you have questions, we can talk about that later, but it's basically like network attached storage sort of thing. And let's say you wanted to use AWS EBS from your Kubernetes pods, you would use persistent volumes to be able to use those. But basically, when you're using the operator, you as a user are directly not creating these volumes. Operator is kind of creating those volumes internally. In fact, operator really delegates it to Kubernetes itself. One of the things I talked about was like the operator is able to destroy a Druid cluster. So when you tell it to destroy a Druid cluster, it goes and wipes the slate clean. Currently, because of this bug in Kubernetes, your persistent volumes are not cleaned up. So you're kind of supposed to go and manually delete those. So it's like a well-known issue, and hopefully it will get fixed, or we'll do something in the special in the operator. But for now, if you delete a Druid cluster, just know that you'll have to manually go and deploy your persistent volumes if you had any. Another thing people hit time to time, this is yet again a bug inside Kubernetes stateful set. It's a known issue where if you were updating something in the stateful set, and let's say you had a typo in your Docker image name, and you wanted to the rolling update, then of course the pod will never be able to start because it will not find the image because of the typo. But even if you went back and corrected the typo and submitted the spec again, Kubernetes is never actually able to recover from that problem, and you'll have to go and manually delete the pod. There is some work happening in the Druid-operator community to kind of work around this by detecting this particular situation and deleting the pod automatically behind the scenes. But given the current state of operator, you might hit this, and so in general, there are some corner cases where you might have to go and do things manually. And we in the operator are trying to reduce the occurrence of those things as much as possible. But currently, typically, if you update something and the operator goes and tries to update the relevant thing in Kubernetes, and Kubernetes does not align the updation of that thing, then you kind of get into the issue where you'll have to go and manually fix the spec before it can make progress. It becomes especially troublesome when you're using rolling update, because it will go to a certain point and it will be just stuck there. So just things to know. But the good thing is we are working hard to fix all these problems as much as possible. And of course, the people here might be wanting to contribute, and these are some of the areas to think about. So yeah, this is kind of a similar issue. So I'll skip this slide. I'll quickly talk probably a little bit about under the hood. Druid operator code uses something called operator SDK. It is basically a library of code that you can use to write Kubernetes operators, because there's a lot of mechanical and boilerplate things inside this operator application, and you don't want to kind of write all of them from scratch. So Operator SDK is a nice library and code generator that you can use to generate the operator scaffolding. Then in the Kubernetes ecosystem, Golang is the preferred language of development. So Druid operator is written in Golang for that reason, not because I don't like Java. I think Java is great. And so is Go. But it's just because the Kubernetes ecosystem has a lot of Go. So it kind of makes sense to have that in Golang. You can find the source code for Druid operator here. If you become curious enough to go and look at the source code, I think the two files you should get started with, you can click these links. So Druid_types is the file where kind of user spec what is submitted to operator is defined. So you can, this is the source of truth about what is the input to operator that user submits. And if you wanted to see a list of what all it supports, you can go and look this file in the source code. Then another thing you can see is the main control loop about like once operator discovers a spec, what it does to make the Druid cluster reality. So if you read this function, you'll kind of see what things it is doing to bring up a Druid cluster for you. So that's in terms of the source code if you wanted to see. In terms of the design, like anything else, Druid operator has the same design. So you would submit the Druid spec to the Kubernetes API server. Druid operator is just watching all the Druid type resources submitted to Kubernetes and running the control loop that is pointing here and basically submitting things back to Kubernetes in order to do things with the Kubernetes Druid cluster. One of the questions that comes up when writing an operator is from the design perspective, whether operator should directly create the pods, which are like the processes. I mean, it's very hard to describe what a pod is if you want to get very technical, but you can think of them being synonymous with containers, loosely speaking. So like one of the design questions that comes up with like whether operator should directly manage the pods or whether operator should manage a little bit of a higher level resources like stateful set, which in turn manage the pods. We kind of went with the route of working with the stateful sets, and the reason being because initially when we had the Druid cluster, we were using stateful sets, so it was just simpler to be so. Also, this is kind of very intuitive for the users who are migrating from their own way of managing Druid cluster to the operator, because stateful sets and other Kubernetes resources, the way users generally deploy Druid cluster on Kubernetes, by switching to operator, most of the task gets automated away, but you will still have all the familiarity that you had with your previous experience of deploying clusters on Kubernetes. You do lose some control when you're not managing the pods directly, but you get a lot of benefits and simplicity in the operator when you don't have to deal with the pods directly. One of the areas where losing that control actually shows up in MiddleManager auto scaling, because Kubernetes resources don't give very good control about when you want to scale down in terms of like, if you're not managing the pods directly, you cannot say when scaling down, first kill this pod, then this pod, and then this pod. Kubernetes kind of has its own ways of selecting the pods to kill. And with MiddleManager and real-time ingestion, we might want to be very prescriptive about like when we are scaling down, which pods we want to kill. So there's some discussion there also, but current reality is the operator manages stateful sets and not the pods directly. Let's see. The last slides about like in terms of specifically like Druid clusters at Splunk. We currently use both AWS and GCP to deploy our infrastructure. I've mostly been involved in deploying Druid and infrastructure on AWS. We kind of use Istio service mesh to manage TLS everywhere. Druid has its own TLS layer, but I think Istio gets used in our systems because we are deploying a lot of different applications, and we wanted to have a standard way of doing TLS for all the applications that are deployed on the Kubernetes. So that's why we use Istio even for Druid. There's nothing wrong with Druid's own support of TLS, but it's just to standardize how we do TLS across all of Kubernetes cluster. When we deploy in AWS, it might not come as a surprise, but we use S3 buckets for deep storage, persistent volumes for historical disk storage, and the RDS that AWS offers. And we have a mixed set of Kubernetes clusters. We have few custom Kubernetes clusters where we just get the virtual machines from the cloud provider, deploy our own Kubernetes clusters. And in some cases, we use like the cloud provided managed Kubernetes services like EKS and GKE. And yeah, one of the things I did want to mention, it's probably not related to Druid or the operator so much. Like I have highlighted the word encrypted here a lot. And the reason being, like if for any reason at any point you think your cluster would need to be security compliance like SOC 2 certification, etc., it's important to have encryption turned on from day one, because for things like persistent state in the disk or deep storage and metadata, if you want to turn on encryption when the cluster is already in place and data is stored, it's a lot of work to migrate to the encrypted state from unencrypted state. So if for any reason you think you might need to be encrypted, just be encrypted from day one. Well, thank you. And I think that's the time for the questions.
There is, and you've got lots of questions out there. That was an awesome presentation. I got some feedback over the social medias that this was the best Druid on Kubernetes presentation that anybody's seen. So thank you so much for this. And I definitely encourage those out there that are beginning their journey with Druid to check out the Druid operator, especially if they're a Kubernetes shop, because it will, I think, help out quite a bit in your journey. So let's start with some questions. Will you be supporting Helm to deploy the operator?
So yes, actually there was already a PR in the community. And at that point, Helm charts, I think, used to be in a Helm specific repo of charts. But sure, it's totally possible to add the Helm charts for deploying the operator inside the operator repository itself if there's a demand for it. There's a PR already. Please go +1 it and we'll take a look at it again. But yeah, most of the people I see who are using Druid operator, they actually use Helm charts today to deploy the operator in Kubernetes. So it's a good thing to support.
Excellent. So how do you see auto-scaling for historicals and middle managers working with the Druid operator?
Right. So as I said, that's one of the futuristic things I think for Druid operator. Druid operator does support adding in your horizontal pod autoscaler feature from Kubernetes. So operator can technically support whatever the Kubernetes built-in horizontal pod autoscaler can do. So for historicals, you can actually use it to scale your historicals up and down. So they're supported. I haven't personally used it, but if you have used the HPA, is what it is, acronym for horizontal pod autoscaler is. If you have used it without the operator, that is totally possible to use even with the operator. I personally don't know how well it works, because when you're auto scaling the historicals, it kind of changes the distribution of root segments across the cluster. So when you go in terms of scaling the historical pods too quickly, coordinator has to load balance all the segments across the historicals. So there might be some Druid specific challenges that people face, but as far as operator itself is concerned, yes, you can enable the auto scaling, it will do, but just check how well Druid itself be able to handle the auto scaling for historicals. For middle managers specifically, operator doesn't do anything special, but I think we want to do something in there so that it is able to manage auto scaling the same way Druid manages. So Druid itself has an auto scaling interface for middle manager, And we are having few conversations both in Druid operator and the Druid itself to see where best to place it. Like one way to support MiddleManager auto scaling would be to just build a Kubernetes extension inside the Druid itself, where you can use the Kubernetes autoscaler from the Druid code itself, so that operator doesn't have to do anything special aside from enabling that particular autoscaler in Druid. So that story is not settled yet, but at some point it should and would support the autoscaling for middle managers.
Great. Do you think you can use this to use automated rollbacks?
So it doesn't automatically roll back, but it does the rolling update. So for example, if you made an update to your Druid cluster and you want to revert back, you can go back and make the change to the spec. So Druid operator will do yet again a rolling deployment of the whole cluster so that you can revert back to the previous state. But it doesn't have a rollback feature as such.
Can the Druid operator handle configs for each Druid process, like the runtime properties or the JVM config?
Yes, that part is like you can control all the configurations and parameters to the finest granularity possible.
And does the operator itself support high availability mode in the case something goes wrong and the operator itself wrong with the operator itself while upgrading the Druid cluster?
Oh, you mean whether the operator itself is highly available, like operator itself goes down?
Yeah.
You can definitely configure operator to run in a HA mode where like you have, let's say, 2 operator pods running. One of them is leader and doing things with it. And that feature kind of comes directly from the operator SDK, the framework we used for deploying the operator. Personally, I haven't used it, but I see no reason for it to not work. So it is there, but untested as far as I'm concerned. That said, I think even if the operator pod goes down, the nice thing about Kubernetes is that Kubernetes itself will bring the pod up again very quickly. So operator might be down only for, let's say, a couple of seconds, a minute, even if you don't do anything special with respect to high availability of the operator itself. So it's basically a deployment resource running with replica count 1. If you wanted like real HA, you can set the replica count 2 and one of them will become leader. But even with replica count 1, if it goes down, it comes up pretty quickly.
And somebody's asking, isn't the Helm and the operator two very different solutions?
Right. So Helm is more like Helm gives a purpose-built scripting language for deploying things in general on Kubernetes. Helm by itself doesn't have any of the Druid knowledge. Druid operator, which shines is it can combine the Kubernetes knowledge and the Druid knowledge both in one place so that you as a user get both in a reusable component. So like initially people used to use Helm a lot for deploying the systems. And I think that's the day one. If you want to deploy a new system on Kubernetes, there is no operator for it. Helm is what typically people use to deploy that system. But you'll have to build your own charts and things like that, which are specific to that system. So Helm can be used, you can still use it, but I personally use the operator. But Helm still gets used to deploy the operator itself. Like operator deploys Druid, but you need something to deploy the operator itself. And that's what currently Helm gets used a lot for. So even in terms of the Kubernetes community, the recommendation and the flow, if you were to go and see, hey, whether I should use Helm or the operator to deploy something, the recommendation would be like use the Helm to deploy the operator and let operator deploy the distributed system. So that's the workflow I would suggest.
Great. Have you considered adding more CRDs to model more of the Druid configuration, perhaps a supervisor CRD?
It doesn't exist today, but sure, if there are enough use cases and there's nice way to do it, it can totally be done. It could be a new CRD or it might be a new thing in the existing spec. I prefer changing the existing spec or adding more to it, but that's a thing that can be discussed and debated in the community. But sure, like in terms of managing the supervisors from the operator as a feature, yeah, that would make sense.
Okay, and the last questions, a Kubernetes questions, but not specific to Druid. Should we separate out nodes to deploy stateful sets from the ones to deploy stateless applications?
So personally, I use stateful sets for deploying all the node types just to keep things simple for myself and for the team. Like in that way, they only have to learn about stateful sets. But it is totally possible to use deployment resources for things like broker, router, etc. And Kubernetes Druid operator now supports using deployments for those. But I personally just use the stateful set for all the node types and haven't had any trouble with them.
Fantastic. Well, thank you so much. Those are all the questions that we had come in. Thanks everybody out there for your participation, and thank you so much, Himanshu, for this fantastic presentation and all your work on the Druid operator.
So thanks all for joining.
So if like Splunk and Nielsen, Zeotap, and our upcoming speaker from Pinterest, you have a story to tell about Apache Druid, please, please, please email us at community@imply.io to find out about all of our ways of getting your story out. It can be as simple as adding you to this Powered By page, or you could come be the next speaker at Druid Summit. We have different options for every level of comfortability of speaking in front of crowds, or even speaking in front of crowds and your cat, which is what I'm currently doing. So anyway, the links to the slides, the recordings of the sessions you just saw will follow shortly. Keep an eye on the Imply blog, ASF Slack, and the Druid Google user group for announcements about Imply's new discourse-powered Druid community forum. We've been doing a number of surveys of the community over the last few years, and the #1 request we had was a better place to get help, more of a question and answer type forum. So we've listened and we've complied, and we are going to be launching a discourse-powered community forum very, very shortly. We're nearing the end of our summit. Our 6th and final session has the awesome title, Archmage, Pinterest's real-time analytics platform on Druid. Again, just gotta love those World of Warcraft references. It's presented by Jin Wang and Jiaqi Ku from Pinterest. So join us in 12 minutes at the top of the hour, just enough time to get a snack and a beverage and get back online. Again, thank you so much for your presentation, Himanshu. We really appreciated it.
Thanks, Rachel.